Hello everyone, and welcome to this video about weight and mass. There is a short video for you to watch in addition to this one, and I'll go through that in a moment. We'll then go through the difference between mass and weight, or weight and mass, and then we'll have a go at some questions. And you will need a calculator for this, as well as your normal book or paper and pen, pencil. So the first video I want you to watch is the one that is on the screen now. You will need to type it into the search bar, as the link won't work if you press it whilst watching this video. So it's bit.ly/weight and mass video. Once you've watched that, come back to this one and we'll carry on with the rest of the lesson. So weight and mass. So just to bring everything into a nutshell from the previous video, mass is what we are, and if we zoomed in on an object, we would see lots and lots and lots of particles or atoms if we go even smaller, and each one would have a certain value of mass, and we would measure that in total in kilograms. Weight is a type of force, and whilst mass is measured in kilograms, forces are always measured in newtons. So if I took myself off to a different planet or to the moon, my mass would stay the same. So the number of kilograms that I am on the Earth and the number of kilograms that I am on the moon would be the same, but the force that I would feel would be different, because the force is related and due to the gravitational field strength of the surroundings that you're part of. Now, one thing that doesn't help in science is when you go home, you might weigh yourself and you might stand on some scales, but actually you're not weighing your weight, you're weighing your mass. At home, it might be measured in stone or in kilograms. So really what you're doing is you're measuring your mass when you stand on there. So we do use the word, what is your weight, in common practice, but in science, mass is always measured in kilograms, your weight is always measured in newtons. So if someone asks you what your weight is, you'll have to correct them, please, and say, actually, are you asking for my weight or are you asking for my mass? Or just tell them it's none of your business. There is an equation for this that helps you move from your mass to your weight. So your weight is equal to your mass multiplied by your gravitational field strength. Now on Earth, it's roughly 10 or 9.8 newtons per kilogram, but quite commonly for ease we do round that up to 10. So if we just look at an example, so if we have 55.7 kilograms, we would then multiply that number by 9.8, and that would give us our weight. So in a calculator, which you absolutely need for your exam, and I'm hoping that you've got one in front of you, 55.7 multiplied by 9.8 equals 545.86, or we can round that to 546 newtons. So our mass would be 55.7 kilograms, but our weight would be 546 newtons. And it is this value that changes depending on the gravitational field strength around us, so depending on the planet that we live on. Now, another complication with this equation is some people don't always use gravitational field strength. Sometimes they use acceleration due to gravity. But in essence, they're the same thing, and they're both 9.8 newtons per kilogram on Earth. So if we're to put some units. Weight, we said, was a type of force, so that's newtons. Mass, we said, kilograms. And then the units for this, newtons per kilogram, or you could also use meters per second squared because it is a type of acceleration. Either are absolutely fine. Some students like to put equations into triangles to help you with rearranging them. So mass and gravity are multiplied together. So mass and gravity. So that leaves weight at the top. Spend a couple of minutes now writing this equation out. Keep checking your answer. This is one that you do need to remember for your exam. So write it out 10, 20 times so that your brain gets used to the idea weight equals mass times gravitational field strength. For short, you could just write W equals M times G. So once you're ready, feel free to move on and we'll go through some questions. Okay, for the first question, calculate the weight of a lunchbox that has a mass of 1.5 kilograms. Well, we said that the gravitational field strength on Earth is 9.8, and you'll be told in the exam what value to use. We'll use 9.8. Hopefully you've memorised the equation, just think it out loud. Weight equals, yeah, you've got it. So weight equals mass times gravity. So then the mass, well, let's think about this. The mass is in kilograms, so that's 1.5. And gravitational field strength is 9.8. So we can again put that into our calculator, so 1.5 multiplied by 9.8. And that gives us a weight of 14.7. Remembering our units, weight is a type of force, so newtons. Okay, this one over to you. So calculate the weight of a bird when it has a mass of 0.75 kilograms. So press pause, give it a go. Remember, write down the equation, write down the answers from the information you have. Use a calculator and remember the final unit. So press pause and when you're ready, restart the video. Okay, so hopefully you've given this a go. So weight equals mass times gravitational field strength. Your mass is 0.75, looking for anything with a kilogram. Gravity, well, gravitational field strength is given to you, so 9.8. Go to your calculator, so 0.75 multiplied by 9.8, and that gives us an answer of 7.35 or 7.4. And remember that weight is a type of force, so in the unit of newtons. Next one. A human experiences a downward force of 440 newtons on Earth. Calculate their mass. So again, we need to know the value for gravity, 9.8. If you write it down enough times, you will just fluently remember it. Now this one, we want to calculate their mass, so we are going to need to probably rearrange that equation. So in your brains, you should have weight equals mass times gravitational field strength. You might wish to turn that into a triangle. So we want to find mass, so that equals weight divided by gravitational field strength. And now we plug in the numbers, 440, value of gravity, 9.8. Go to our calculator, 440 divided by 9.8 gives us a mass of 44.9. And remember our units, mass is measured in kilograms, 44.9 kilograms. Okay, over to you. So same principle as before. Value of gravity is 9.8. You know the equation. You're going to need to rearrange it. So press pause, have a go, and when you're ready, resume by pressing start. Okay, hopefully you've got an answer. So we start with the equation, weight equals mass times gravity, and then we need to rearrange. So we put it into our triangle if we need to. So then mass equals weight divided by gravitational field strength. Weight, well, the unit of weight is a force, so we're looking for anything with a newton next to it. So 890. The value of gravity is 9.8. And again, we find our calculator, 890 divided by 9.8. And that gives us a mass of 90.8. And reminder that the unit of mass is kilograms. So 90.8 kilograms. Next question. Calculate the acceleration due to gravity on a planet where an astronaut has a mass of 85 kilograms but weighs 310 newtons. So this time we want to find the acceleration due to gravity, and if you remember, that's also equal to the gravitational field strength. It's just another way of saying it. So at this point, have a go. Remember the equation, rearrange, plug in the numbers, use a calculator, remember the unit at the end. So press pause, and when you're ready, resume. Okay, weight equals mass times gravity. Turn it into a triangle. This time we want to find the acceleration due to gravity. So G equals W over M. The weight, well, weight is a type of force. There's a clue there as well, so 310. The mass is measured in kilograms, and there's a clue because it's got the word mass in this case, so 85. And we can put that back into our calculator, 310 divided by 85. So the value of gravity here is 3.6, and our unit, well, there's two to choose from, newtons per kilogram, or the other one that you could have used is meters per second squared because it's an acceleration. On to our final question then for the video. A robot exploring Planet X weighs 1,900 newtons. It has a mass of 340 kilograms. What's the gravitational field strength on Planet X? So again, press pause, have a go, and then when you're ready, press play again. So as ever, we write down the equation. Weight equals mass times gravity, or gravitational field strength. We might want to turn that straight into a triangle. Find out what we need to do. So we're trying to find the gravitational field strength. So G equals, and it equals W over M. We've got our weight, 1900. We've got our mass, 340. We've got our calculator, so we can type in 1900 divided by 340. So the value for gravity on here rounds to 5.6, and our units, if you can remember, newtons per kilogram or meters per second squared. Well, that brings us to the end of our weight and mass video. Hopefully you saw the first video. Hopefully you have a better understanding of mass and weight, mass in kilograms, weight in newtons, and we also went through some questions as well.